skulle beskriva liksom...
Okay, good afternoon. So let us continue our lesson of factoring polynomials. Before teaching you the new lesson, factoring polynomials using conjugate and squaring rules, let me just refresh your memory about factoring polynomials that we started and then solve a little bit harder problems. And then we continue to this lesson. So I told you that when I ask you to factorize a polynomial, it means that write that polynomial as a product. Yes? And then usually you have to continue this as much as you can so that the factors left for you are not factorizable anymore. Okay? So let me just write an example here to review a little bit. So example. Factorize as much as possible. Yes. So number one. So I just want to make sure that you know this is a very simple one. So x squared plus x. So what is the answer if I want to factor? What can I factor out? You should be able to do this immediately. So you need to write this as a product so that when you multiply it back, it gives you this. So what's the answer, yes?
You factorize out x, so it's x plus 1.
Plus 1, yes? So why is that the correct one? Because first of all, this equality is true. Why? Because if I multiply this back, x times x is x squared, x times 1 is x, so that's correct. And now if I ask you, is this a product? You will say yes, that's a product between x on the one hand and x plus 1 on the other hand. And then I cannot factorize more, so that's the end of this problem, yes? Okay, let us just continue. Number 2. So 5acx, and then I have 15cx. So I want to factorize this. So what can I, so you need to take as much as you can out, yes? So what is the, between numbers 5 and 15, what is the highest common factor? Is 5. So I pull it out, 5. A is not a factor in common, but C and X are. So I pull both of them out. So you need to write something so that when you multiply it back, it gives you this expression. And that is easy. What can I write here? It's just A. And then what can I write instead of that? It's just 3, yes? I always recommend you, at least for the first times, you need to check it once more by multiplying it back in your head. If I multiply this back in my head, it becomes that. And if I multiply this by that, it becomes this. So that's correct. And I cannot continue further. So, for example, number 3. What can I write for this one? 7x cubed, y cubed, z squared. And then I have minus 3xy cubed, z cubed. So let me make it x squared. And then minus x cubed, y squared, z cubed. Yes? So if I want to factor something out, what is that expression that I can pull out here? The maximal actually factors in common. You have to pull them out. So between numbers 7, minus 3, and minus 1, I don't have anything in common except 1. So for numbers, I can do nothing. But for x variables, here 3 factors appear, here 2 factors appear, and here again 3 factors appear. So the highest factor of x that appears is x to the power of 2. And that for the same reason, the highest power of y that appears is again 2, and the highest power of z that appears is 2. So I can pull y squared and z squared out, yes? And then I need to write something in the pair of brackets so that when I multiply this back, I will get the same expression. And I don't think it is hard. So for example, what is left from the first one? What is that?
7xy.
Yes, 7xy. So 7xy is left for the first one. Then I have negative 3. X squared is pulled out. 2 y's and 2 z's are pulled out. So 1 y and 1 z are left. And then for the last one, what is left for me is just x and z. So it's minus x and z. That's the factoring this. Yes. But I didn't actually give you an example. When I checked the book, I saw that there are some examples of this type that I want to mention here. So number 4, for example, I have seen some exercises in the book like this. So then I will give you more examples now. So for example, you have this. 5a plus b, and then you have b, a plus b. For example, like this. You are supposed to factor this expression. So you need to write this as a product. So this part is a product, this part is a product, but the whole expression is not in the form of the product. Actually, the whole expression is a sum between this and that. So it's not a factorized formula. But hopefully you realize, if I ask you what are the factors involved in the first one, you will say 5 is one factor and a plus b is another factor. And if I ask you the same question for here, you will say that b is a factor, a plus b is another factor. So you immediately realize that a plus b is a factor for both of them. So this means that this can be pulled out. So a plus b can be pulled out. When I pull it out, so what is left from here is 5. And then I have plus what is left from here. When I put this out, then it becomes b. Yes? So you might get a little bit confused. You say that, okay, Babak, you told me that if I multiply it back, it will give me this. And if I start multiplying, it gives me 5ab plus 5b plus b squared. And this is not this one. That is actually this one. If you are patient and multiply this one also back, yes? So if you multiply it here, it becomes 5a, 5b. If you multiply it here, it becomes b squared. And if I multiply it like that, it works. But the point is that I want you to compare it with this problem, you know? I want you to compare this problem with this problem. Let us say a plus b and a. Yes, I have given the role of a plus b to this capital A. If I ask you to factorize this, I don't think you will face a problem because you see that a is in common. You factor the capital A, and what is left is 5, and what is left here is b. Okay, and you see this expression is exactly the one that I have written here. And if I ask you what is capital A is a plus b. Yes, that's also something that you really need to know for more advanced problems. Of course, you don't face that big problem in factorizing here, but if you want to understand deeper, this you need to know. So let me give you some examples of this type, okay? So I want to factorize this. Okay, so then is it possible to factorize it? Yes, I would say that the first one is a product of 3 factors. One is a, one is b, and one is x squared plus y as a whole. And then the next one, I have 2 and x squared plus y. And then you immediately realize x squared plus y is the factor in common. And you can pull it out, yes? So this becomes x squared plus y. If I pull it out, by pulling it out, by the way, if I want to be very precise, it means that I divide. When I say that I pull it out, it means that in my head, I write this, and I divide it by what I am pulling out. But then this one and that one are simplified when I divide. What is left is AB. Yes? This is the real one, what I do. And then if I pull this out, it means that I divide this by x squared plus y. What is left for me is plus 2. So that is the factorized form. Why? First of all, it is equal to the expression that I had, and then it is in the form of a product. It is the product of x squared plus y and AB plus 2. Yes? Okay. So let me take this one into account. So what do you think about this? So number 6. What happens if I want to factorize, for example, 6y minus 1 to the power of 4? That's also a good question. 4y minus 1 to the power of 3. So we want to factorize this. I want you to make sure that you really understand what's going on. Yes? Can I pull something out? First of all, you see that this is not in the factorized form yet. Because if I ask you, is this a product or a sum? Definitely you will say this is the sum between these two. So that is not a product in this format. But can I pull something out? I need to find the common factors. So what are the common factors? Between numbers is what? Between numbers is 2. Yes, so I can pull a 2 out. Okay, what more can I pull out? Can you see that? Yes, Bure?
X minus 1 cubed.
Y minus 1 cubed. Yes, y minus 1 cubed, I can pull it out. But this you need to be careful a little bit. Let me write everything. Okay, so I divide it in my head by 2. When I say I pull out, it means I divide. So it becomes 3. And then there are 4 factors of y minus 1. I've pulled 3 of them out. So if I divide it in my head, 1 is left. But if you write it like this, this is wrong. Yes, you have to put this in the pair of brackets. Okay, this is finished. And now I have the plus sign here. And then I do the same thing here. I divide the whole expression by this one. 4 divided by 2 is 2, so 2 is left for me. And this expression divided by that expression becomes 1. If you want, you can write multiplied by 1, but there is no necessity to do that. Technically, this is done because it is written in the form of a product. But no one in mathematics usually leave this and just like that, because you have an extra pair of brackets that you don't need. It's better to remove it. Okay? Not removing this, by the way, don't get confused. The logic is not to start multiplying to remove every pair of brackets. Don't get confused. If I ask you to expand this, it's harder. You have to write this 4 times multiplied by itself, 3 times multiplied by itself, expand them and add them. That is expansion. The goal is not expansion here at all. The goal is to write an expression equal to that, but in the form of a product. Okay, so here I just simplified this a little bit. So it means that without touching these two, because they are already in the simplified form, so I just copy and paste that. But here I can do a little bit better. I multiply this in, so this becomes 3y minus 3, and then I have an extra 2 at the end. And then a minus 3 plus 2 becomes minus 1. It's important actually not to stop here, even though technically you are done. If you really want to follow definition, yes, this is really a product, so it can be considered as the factorized form of my expression. But remember that I am simplifying this factor. Instead of writing it so long, I am writing it so short. So that is the best part to start. Okay, let me give you a little bit more tricky example. So number 7. So I have 4a, and then I have 3x minus y squared. Then I have plus 6ax y minus 3x, and then I will have plus 10ay, and then I have 3x minus y. Yes, this might be a little bit more tricky if you want to solve that. Okay, so how should I do this? May you please close the door? Thank you. Thank you. Thank you. Okay, so what can I do here? I want to wait for you a little bit so that you can do it. Can you hint me somehow what to do? Is there something in common? From numbers point of view, what is the number in common? The highest common number? 2. 2 is the highest number. For the letters or the letter parts, A is also in common. Yes? But can you tell me if something else is also in common? Yes, Oscar?
Well, I mean, the like 3x minus 1. I mean, in the middle one, it's y minus 3x, but you have to pull 1 minus out.
Exactly. So that is the trick. That's the point. You see, 3x minus y and 3x minus y are in common in these two, but this is not 3x minus y, that's y minus 3x, and they are technically different, yes? But they are not that different. The only difference is the minus sign. I told you even in Math 1C, whenever this happens, you can just interchange them, but there is a price to pay, is that change the sign from positive to negative or from negative to positive, yes? So the first thing that I do for this problem, if you want, I can just copy and paste everything except the middle one. In the middle one, I write minus 6ax. Then I am allowed to interchange them. Yes? And then I copy and paste the rest. Now everything is ready to factorize. So from numbers, I have 2 in common. Letter A, the highest power is A. And from this factor, 3x minus y, I have 2 factors here, 1 factor here, 1 factor there. So at most, I can pull out 1 factor out. And then I open a pair of brackets here, and then see that what are left. So what is left from the first term? 4 divided by 2, 2 is left. A divided by A, 1 is left, multiplied by 1, which I don't write. But this, I had 2 factors. I divide by one of them is still left. And don't get confused. You have to use pair of brackets here. But then I reach the negative sign, so I put negative, and I do the same thing. I divide 6 by 2, it becomes 3. I divide A by A, it becomes 1. 3 times 1 is just 3. And I divide A by nothing. I divide X by nothing. There's nothing to divide. So X is left. Yes? And 3x minus y divided by 3x minus y is 1. I don't write it down. And then I will have 5, y5, because 10 divided by this 2 that I pulled out is 5. A is gone, but y is left. 3x minus y is also gone. So that is what I get. And if you don't mind, let me make it closer here. So technically, this is a product. I can stop here, but I told you that. Hopefully you understand that it is better to simplify. And by the way, you will see that in this case, it is really important to simplify, even from factoring point of view. Why? Let us see. So this becomes 2a. I copy and paste these parts. And then I start multiplying. So it becomes 6x minus 2y. And then I have minus 3x plus 5y. And then what I do, I simplify this. 6x minus 3x is how much? Is 3x. Minus 2y plus 5y is positive 3y. Yes? So that is a coincidence. You see, in the previous problem, coming from here to here is just a matter of simplification, no more. But here, it is not just a matter of simplification. If you do not do the simplification, your factorization is not complete, Because when you simplify, you get another factor in common, which was not apparent from the beginning. So that is important. You see, if you do this and stop here, still the problem is not complete, because suddenly this is not something that you can foresee before. You have to do it. Then suddenly a 3 appears in common, and then you have to pull it out again. Okay? Because I told you that, first of all, I have mentioned as much as possible. Even if I don't mention it implicitly, always by default, it means as much as possible. Yes? So this means that I have to continue now. It's important to pull a 3 out. When I pull a 3 out, this will multiply here. It becomes 6a, and then 3x minus y, and then it becomes x plus y. So this is essential. You see, here simplification is essential if you want to complete your factorization. Any questions? Okay, let me just give you one more example. I want you to understand that this is I have only mentioned 2 terms expressions here, 2-term expressions, but you can actually have more than 2. For example, which number is that? Let me bring it up for you. Yes. So number 8. So you can have this, for example, x squared times x squared plus 1 plus x plus 1 minus x squared plus x plus 1, and then plus x squared plus x plus 1. Yes. So assume that I want to factorize this. Don't get confused. Don't confuse the logic. When you reach to this point, you have to stop. But if I ask you expand this, you still continue by removing pairs of brackets. Don't confuse the logic. Okay, here, what can I do? Can I factorize something out immediately? Yes?
X squared plus x plus 1.
Yes, if you look closer, this is already in the package. It's C, but it doesn't matter. You can yourself assume a pair of brackets around these 3, and then you see that there is a factor in common, and that factor is x squared plus x plus 1. So I can pull it out. Okay, just help me to write the answer. So x squared plus x plus 1. I pulled it out. I open a pair of brackets here to fill it up. Okay, I pulled this one out from the whole first term. X squared survives. Yes, I divide this expression by that expression. X squared is left. I have a negative sign. When I do the division, x is left. Okay, can you tell me what happens for the last term, or is it done? Is it finished, or I need to continue? Someone else, Ali, yes?
You need to write plus 1.
Plus 1, thank you. For this example, I have seen students continue by conjugate rule. Actually true, that is a conjugate rule, but you have to stop here because the goal is not to expand. The goal is to write as a product. So you see, just read. If I give you in the exam and ask you use the conjugate rule to expand, yes, that's a different problem. So you come here. For example, you can imagine it in this way: x squared plus 1 plus x, x squared plus 1 minus x. Then this you can take as a box, and then this one as the circle. Then you see that the conjugate pattern emerges. But don't get confused. If you continue, it means that what you have done right, you are making it wrong. You have to stop. Okay, any questions so far? Now we go to the new lesson. Okay, so as I have written here, I want to use conjugate and squaring rules. And if you don't mind, because I taught you squaring rule first, so let me start from the squaring. I told you that actually the factorization is a little bit hard because that is the reverse process, yes? So in the squaring rule, we have this formula. We have a squared, we have a plus b, then squared. This becomes the first one squared, 2 times the first one times the second one, plus the second one squared. So now the whole point is that the right-hand side somehow is given to you. You need to train your eyes to immediately detect this pattern. This pattern is a trinomial. Trinomial means 3 terms are involved. And then 2 squares are there, 2 complete squares are there, but that is not enough. The middle term should have the correct form. The correct form is that it is 2 times the square root of this one times the square root of that one. So this means that expansion goes from here to here. That is expansion. In this direction, it's factoring using the squaring rule. So the only thing that you need to learn, this is not something that I can teach you more than that. You need to detect, train your eyes to be able to catch this pattern immediately. Yes? So for example, if I ask you factorize this expression, so for example, I can give you this and I ask you factorize this. So first of all, I don't know, can you detect this pattern here? So why you should be suspicious about that this pattern might work here, and then you have to confirm that if really it works or not. Why? Because first of all, I have 3 terms. Here I also have 3 terms. I have 2 complete squares. One of them is x2, one of them is 4. I also need 2 complete squares. So far, so good. But don't be in a hurry. You have to check the middle term as well. Is the middle term in the right form? How should I go? You go to scratch paper or in your head. Take the square root of this, becomes x. Take the square root of that, it becomes 2. Multiply them, it becomes this AB. And then multiply it by an extra 2 all this. And see what happens. It becomes 4x. Is the middle term 4x? The answer is yes. So this is indeed the pattern. So the answer is what? The answer is something like this, because this is positive with the positive in between. Take the square root of one of them, write first. Take the square root of the other one, write second. That's your answer. By the way, why this is in factorized form? Because power of 2 means?
It's just multiplied by itself.
Multiplied by itself. So power of 2 is also a product form. So you see, whenever I give you such a thing, but if I give you this, what happens? Is this a squaring rule?
No.
It's tempting to say yes, but it is not. Why? Because it is 3 terms, good. It has 2 complete squares, but the middle term should be 4x, but it is 2x. Then you might ask, is it possible in any other way to factorize it? It is a sensible question, but you don't need to be worried about that. We will study this somehow later, these quadratic polynomials. So in this case, you will see that no, you cannot factorize it on the set of real numbers. Okay, I will talk about this one as well. Okay, so let me just, by the way, talk about this here, because usually when I ask you to factorize, I have to give you the field on which you are allowed to factorize. For example, do you think this is factorized? I can write it. Do you detect any, let me ask you in this way, do you detect any kind of pattern here? Now that is not a good example, because this is possible. Now let me tell you like this. Sorry. What do you think here? Can you detect such a pattern here? So such a pattern exists here, yes? Because you can say this is a square root of 3x plus 1 squared. Let us double check. The first one squared becomes this. 2 times the first one times the second one becomes this. And the second one squared becomes this. So if you write it like this, that is completely right. So, but you see the numbers that I am using here are irrational numbers. It doesn't have any problems. This is why I want you to understand when they ask you to factorize, yes, they should also give you on which set of numbers I am allowed to factorize. Yes? So if they say that factorize on the set of real numbers, because the square root of 3 is a real number, this is acceptable. But by default, from now on, remember, by default, when I talk about factorization, I mean over the set of integers. Yes? If I don't mention that what is the field, what is the set of what is the set of the factorization, you need to take it by default, the set of natural integers. So it means that if I give you this, then you don't factorize it anymore. Because if you want to factorize it, you have to involve square root of 3. I will talk about this a little bit later, so don't get confused right now about these details, okay? What I want you to learn is to detect this pattern. By the way, do you remember if it was negative sign involved here, there is only one slight difference, and that would be negative. Yes? Okay. So let me write some examples here for you. So let us do some practice here together. So do you think this is a pattern or not? This pattern or not? 4b to the 4 plus 4b squared plus 1. Is this the squaring pattern, yes or no? And if it is, let me just tell you how to think. First of all, how do you get suspicious that if this is the pattern? You have 3 terms involved, a good sign. The second thing is that you need to have 2 complete squares. The good news is that you have 3 of them involved here. This one is completely square, this one is also a complete square, that one is also a complete square. But the middle term is important, yes.
I'm curious about like the terms, or what exactly does a completed square mean?
That's a good question. Yeah, that's exactly what I told you, because I told you that 2, the complete square in numbers is clear. Because when you say 2 is not a complete square, even though you can write it as a complete square in this 4. Yes? This is, in numbers, it is clear how to define that. We say a number is a complete square if it is a square of a natural number, okay, or an integer or something. So in that case, I will not consider 2, but you can talk a little bit about the variable x. Yes? So you can say that this can also be written like this if x is positive. So is this a complete square? I would say no. So let us define complete square as a square of a polynomial. And in polynomials, we are not allowed to have rational expression, rational powers or negative powers, something like that. Okay. So now, anyway, I don't know. Can you detect the pattern and answer something here if that is the case? If it is not, just ignore that. Is it this pattern or not for some choices of A and B? Yes, Ali?
4b to the power of 2 plus 1.
No. A little bit of mistake. 2b to power 2. Yes? 2b. So 2b squared plus 1. Do you agree that this is working? Check it in your head. This one to power 2 is this one. 2 times this one multiplied by that one is this one. And this one is squared is that one. So that's right. Yes or no? Okay. By the way, let me solve this problem for you. So that's the one that I wrote and erased that. What do you think about this? Can I use somehow this pattern or no? Yes?
Well, I mean, unless you use square root of 2, no, right?
No, that's a good question. When I don't write something by default, I mean the set of integers.
Yeah.
So in your factorization, if square root signs are appearing, I don't want them. That's not acceptable. That's what I mean. Here, when I don't say anything, which I usually don't, I by default mean the set of integers. So what you said is correct, actually. By the way, remember this. If you write like this equality is right, because this 1 to power 2 becomes that one. 2 times this one, let me write it for you. 2 times this times that. The square root of 2, a square root of 2 is 2 times 2 is 4, xy. So that's also correct. And this 1 to power 2 is that one. So if you write this is equal to this, I accept that this is true. But this square root of 2 is not acceptable in this case because that's not a rational number. It's not an integer. But what can I do? This is an important example, yes?
You can factorize 2.
Yes, that is, remember. The previous trick that we discussed here has priority to every other tricks, to every other technique that you will learn from now on. Yes? So here, do you remember what was the trick? If I can pull something out from the whole expression, first of all, do it and then think if there is another method applicable or not. So remember this remark, okay? Taking out the common factor has priority over other techniques that are common. Is it possible to factor something out?
Yeah.
So first do it and then think what will happen. So extremely important. Write it somewhere so don't forget about it. So I factor 2 out first, and then I will ask myself, can I continue further or not? Now, can I continue further? Yes?
Yeah, and that
This is a squaring pattern. Yes? So this becomes 2, and then I would write x plus y squared. So that's the correct acceptable answer. By the way, you see that if you write this in the exam, it is not totally wrong, because here you can also continue and factor a square root of 2 out, and then totally squared. But then square root of 2 to power 2 becomes that 2, and then x plus y to the power of 2 is that one. So if you do it in this way and continue up to that point, it is still true. But I don't recommend that, because that's a rule of thumb. I always use it myself. Whenever I can factor something out from all the terms, not just 1, 2 terms or 3 terms, all the terms, do that one and then start thinking, what can I do with the rest? Yes? Okay, so that's also good to know. What about this one, for example? Can you factorize this? Let me see how many of you listened actually here. So 4a squared plus 9b squared minus 12ab. Do you somehow detect this pattern in that? Yes? So why I should think about this pattern? Because there are 3 terms involved. 2 of them are complete squares. And then the middle one is important. So the third one is, you go to scratch paper or you do it in your head. Take a square root of this is 2a. Take square root of this is 3b. Multiply them, but you always have to multiply by extra 2 because of the 2 in the formula. Then it becomes what? 12ab. Is 12ab here? Yes. So that is the pattern. Yes? So what can I write? I can write a square like this. Because this one is negative, definitely is negative here. Take the square root of one of them. It doesn't matter which one, because you have a power of 2. Even if you write it the other way around, it doesn't matter. But here, let us keep the order. It becomes 2a. Square root of this one is 3b. So that is what I want you to understand. Whenever you see this, you really don't need to explain anything. Be able to write this immediately. That is the goal of this lesson. Is that clear? So let me give you some more examples. What about this one? So how can I factorize this? So I told you that's the important thing. The first thing, so learn this. If you want to factorize, because in Math 2C you have only 3 ways of factorizing. It's not hard. The first one was this trick to pull the common factor out. The second one is this one, squaring pattern, and the last one would be conjugate pattern. But I told you as a remark, this technique has priority over the other two. So whenever you can use the first technique, do it and then think what to do for the rest. So can I pull something out here? Yes. What is that? Pull the most out of it. What is that I can pull out?
X.
Only x. So I pull x out, it becomes 9x squared minus 48xy, and then plus 64y squared. Even if you don't succeed to continue, if there are 2 points for this question, you will get 1 point here. That is important to detect this pattern. And then don't just leave it without thinking. Is this any new pattern or not? And I hope that you see this is squaring pattern, yes? So what you can do, you can write x, and then why this is a squaring pattern? Because there are 3 terms involved. You go to a scratch paper, take the square root of the first one, it is 3x, take the square root of the other one is 8y, and then multiply them, and you yourself have to multiply by a 2. If you multiply that, it becomes 48xy. And that's exactly the number that you see, the expression that you see. So that is exactly the pattern. So it becomes 3x, 8y. Yes? So that is the pattern. Any questions? Okay. And now, let me give you one more and then we go to the next pattern. So what do you think about this? Do you think that this is also a pattern here or not? X plus 2 to the power of 2 plus 2y plus 2, x plus 2, and then I have y plus 2 to the power of 2. Yes? Can you detect the same kind of pattern here? But it is clear this one is playing the role of A, and this one is playing the role of B. So do you see the pattern, or should I explain it more? So what can I write if you see the pattern? So I need to write this one to power 2. This middle one is positive. Okay, what should I write here and there? What should I write here?
X plus 2.
X plus 2. And what should I write there?
Y.
Y plus 2. This is correct, but I will not stop here because I have extra pairs of brackets unnecessarily there. So can I remove these? I can remove these, it becomes x plus 2. I can remove these, it becomes y plus 2. But no one writes 2 here, 2 there. 2 plus 2 is 4. So the answer is what? X plus y plus 4 to power 2. So what I expect you, when I give you this to factorize, detect that pattern, and then go up to here. That's important. Of course, if you are here, you understood what's going on, but I expect you to be able to continue until the end. Questions here? Understandable? Okay, but I would say that conjugate pattern is easier to detect. Because what is the answer to the conjugate pattern? The difference of 2 complete squares. Whenever you have the difference of 2 complete squares, you have to think about the conjugate rule. Okay, so let me remind you of the conjugate pattern. So do you remember when I have this box, whatever inside minus whatever inside, and then I multiply it by that, it becomes the first one squared, always minus the second one squared. So from here to here is expansion. From here to here is factorization. I hope that you agree with me. This is factorized form. Yes, that's a product. And this is very easy. As soon as you have the difference, let me see, I am just emphasizing difference of two complete squares, then it becomes a conjugate pattern. So for example, is this a conjugate pattern? If I ask you to factorize this, yes. So what can I write? I can write x minus y, x plus y. Yes? What do you think? Do you think this is also a conjugate pattern? It's also the difference of two complete squares. Okay, can you help me to do it? What should I write? I open two pairs of brackets because as soon as I immediately as I detect this is the conjugate pattern, I do this. I put minus in one of them, positive in the other one. So what can I write here and there? X squared minus y squared. And then the other one is, but is the problem finalized?
No.
No, because there is another conjugate pattern involved. If you stop here, it's correct, not complete. So what I do, I just do another conjugate pattern here. So this becomes x minus y, x plus y, but then I have to copy and paste this one. And don't get confused. The sum of two complete squares is not factorizable if you want to work on real numbers. In the complex numbers, yes, that can also be factorized. But in the course that we have, we just stop here, we do not factorize that. So is that understandable? So the factorized form, the fully factorized form of this is this expression. What about this one, by the way? X to the power of 3, y, minus x, y3. Can you factorize this? Is it conjugate pattern in this form? No. But I told you, which method has the priority? If you can pull something out first, do it and then think about the rest. What can I pull out?
xy.
xy. What is left? X squared minus y squared. Is it finished?
No.
No, because now conjugate pattern reveals, yes, itself emerges. So this becomes xy, x minus y, x plus y. Yes? Yes, is that clear? Okay, so what about this one? Is this also a conjugate rule? Yes, I have the difference of two complete squares. So what happens? I write 3x squared minus 4y squared, and then 3x squared plus 4y squared. In your lesson, you have to stop here. Can I continue more? Yes, if I allow you to work in real numbers. Why is that? Can you find, so if I give you this in the exam, I will not explain more because by default, I mean that you continue until you are working with integers. If I want to continue more, I can, but I have to use square roots. Can you tell me what can I do if I want to continue? This is the sum of two expressions, so there is no hope for that. If I want to do that, I have to go to even more complicated field. But here you might say that instead of this, I can write square root of 3x minus 2y multiplied by square root of 3x plus 2y. You see, Do you see, if I ask you what is the answer to this part, I hope that you can detect the conjugate pattern. You will tell me this 1 squared, which becomes 3x squared, minus this 1 squared, which is 4y squared. So this is not wrong. It's actually correct to say this is equal to that. But you see, I have used a square root of 3, which is not an integer. So if you have some applications and you want to use the application to factorize, usually you will see the application will ask you on which domain you want to do the factorization. If you just say nothing, probably depending on the application you are using, it will take it probably the integers by default. But if you want to do the factorization in the more extended field, then you need to provide the information. For example, I haven't checked GeoGebra, but for example, if I want to continue up to here, I have to somehow tell to GeoGebra, factorize this on the real numbers. Then it means that I am telling GeoGebra that the square root of 3 is allowed. But if not, I think that GeoGebra will actually stay here. We can check, by the way, by Wolfram Alpha to see how it goes later, okay? Any questions here? No? Okay, so you only learned 3 techniques, and then here, officially, chapter 2 is finished. I was thinking that I will continue to the next chapter, and we will have 2 chapters combined for the next test, because we will not have time to have 2 tests, because we have to save time. There are many important things left here so that I want to cover. And the next part is also algebra, but algebra of quadratic equations. So let us combine these 2, or at least half part of the other chapter for the next test. But officially, the lesson for chapter 2 here is finished. And it was 2 parts. Part 1 was solving systems of equations, if you remember long back, solving systems of 2 equations in 2 unknowns, 3 equations in 3 unknowns. And then we also start learning about multiplying polynomials a little bit, remind you, and then algebraic identities, and then factorization. So 3 main parts. I will write them down for you, don't worry, but I just want to mention that officially chapter 2 here is finished. Okay, if you don't have any questions, I stop this video, and then I will update the Google Classroom so that you can follow what to do. Yes, any questions? Okay, thank you. Thank you very much, people at home.
Jag undrar hur långt man kan gå med det då.